Yes, hello everyone, and welcome to our September meetup. I'm really glad to see you guys all here, or all you guys here today. I think this is the at least according to Meetup.com, this is one of the biggest like meetups we have arranged here in Turku. So really happy to see that growth. As you probably know, we are a CNCF meetup, which means we work under the CNCF code of conduct. Pretty much, it's be nice to each other and behave. Was there anything else I was gonna...
Kubernetes Community Day.
Oh yeah, in 2 months we will be arranging a new thing called Kubernetes Community Day. It will be arranged over in Stockholm, so you pretty much go on the boat here from Turku, travel over to Stockholm, and then there is a full day of events with speakers from all over the Nordic countries. I'm not sure if I can go myself, but I will try to attend. And if there are more people interested, reach out to me, and we can like travel together, make a nice group. And with that said, I think we hand it.
Introduce it.
Oh yeah, my name is Anton Lindholm, and I've been arranging these meetups for like 2 years now, plus or yeah. It has been COVID, so we have had a small pause, but we will slowly but surely start to do this more actively again. And yeah, with that said, I think we'll hand over to Voi and Heidi from Gofore for the practicalities.
Yes, hi everybody. I am very happy to see so many faces. I'm part of Gofore. Welcome. Happy that you're here. Happy that you took the night off to from your other life to come and hang out with us and have nice discussions and have some listen to great speakers. My name is Vio Barinici. I do recruitment here at Gofore in Turku. I have a few of my great colleagues here with me. This is Heidi. She is the queen of our office. Nothing runs here without Heidi. She's going to let you know in a little while about all the practicalities. Then we have Kim, which is our cloud superhero. That is going to have an actual part in this whole speaker part here in a few minutes. Then we have another superhero, Juha, superhero in cloud, and Jussi, the third superhero of tonight, is from Gofore. So all of us are going to host you guys. If you want to talk about Gofore, recruitment, or anything easy like that, I'm your girl. Anything about the office, that's Heidi, and all the hard stuff and all the important stuff, that's Kim and Juha and Jussi in the back. So we're happy to have you guys here, and nice to meet you. How does this work?
You just hold it in your hand.
Okay.
It's Automagic.
Okay, great. Yes. Yes. Hello, guys, and welcome. Also from my behalf, I will just let you know the most important things here. We have several fridges here, so go and grab a drink from there, whatever you want. And toilets. Here is the closest one, and also in the other end of the office we have the kitchen there, and there are also 3 toilets. And shall I speak about the food? Yeah, sure. Yeah, please. Yes, we have hamburgers here tonight, no meat and halloumi burgers, and they are all here in the middle. There is this meeting room, so all is placed there, so you can just go and grab food from there. Yeah, I think these were the most important.
Yeah, I think so as well. I think according to the timetable, I think we will do so. We eat first, and then after that, Kim takes over, has his speech, and then Mathias Fredriksson unfortunately got the autumn flu, so he is out today. But what we're gonna do is that first I keep my presentation, and then after that I'm gonna go wild and do like a live demo of my work environment, how I work, all the small tips and tricks. So let's pray to the demo god. Everything will work out. I might sacrifice a USB driver too here while we eat, so they're happy. But yeah, should we do like half an hour for food and then start after that?
Yeah, sounds good. Yeah.
Nice, excellent stuff. So yeah, let's try to find the food then.
Yeah.
Jussi, you can show the way over there. Follow him.
So let's try 6 o'clock. Yes, hopefully the food was excellent. At least my burger was really good. I think we'll proceed as follows. So Kim starts with his demo, and then after that, like short break, so I can get my computer up and running, and then I do my first demo, and then another short break, so people can mingle and whatnot. And then we do the live demo after that, and then let's see how the evening proceeds. But yeah, big applause for Kim.
Thank you very much, and also on my behalf, welcome to Turku office here, Gofore office. My name is Kim Sjöholm, and I work here at Gofore as a cloud and a DevOps consultant. My background, I have been in different software development projects for about 20 plus years, so I'm quite old. And later on, I started to more concentrate on infrastructure, on-prem setups, cloud, DevOps for these software development projects. And thereby, it was where I came in contact with Kubernetes. My presentation today is a real working solution that we have for a customer, where we have set up Kubernetes to work on AWS. So maybe we can start with a show of hands. Is here anybody who has set up Kubernetes on AWS or maintaining a... Okay, so I need to not lie that much. Okay, so today I'm trying to go through these areas. So what do we have for requirements for this project? And really basic setup of AWS or EKS on Amazon. What else do you need than just the basic parts to make a working cluster? It's not just you have something working and that's it. You need to have something add-ons as well. What it means to maintain this setup, it's not just okay to put it up and leave it there. It just doesn't work like that. Some pros and cons, and finally I try to answer some questions. So I'm not an expert in detail, so please don't make so hard questions to me. Okay, on to the project requirements. So what are the customer and development expectations? Everything should be running 24/7. The system should mainly handle HTTPS requests, where we can have production loads more than 5,000 requests per minute at peak hours. The features are deployed as microservices, so we are using microservices architecture, and this solution should also grow over time, so we can add more and more new features without breaking the setup as such. It should kind of grow with it. From the development side, we want to have own environments for using development, for testing, and for production. So we don't want to test on production. I guess that everybody agrees with that. It's not a good idea. And we also want to have as automated deployments as possible. So we don't want to develop a feature and then have somebody else deploy it onto the different environments sometimes later on. It should be kind of one pipeline. And of course, from the customer point of view, it should be cost efficient. Meaning that if we don't have that much request into the system, then it should scale down. And if we have many requests into the system, then it should scale up. So here I have drawn a basic or the basic setup for our solution. I just want to emphasize that this is not the only way you can set up EKS on Amazon or AWS. This is just how we have set it up. So for those who are not so familiar with this setup, you get this managed service, this AKS, and what do you actually get? What is on your responsibility and what will AWS take care of? So on the left side, we see that the control plane is what we kind of buy. This is what we get. And if you have tried to set up a control plane on your own on-prem, you know that it's not that straightforward. You can get it up and running, but how to maintain it and such, it's not so easy. So that is what we kind of buy from AWS. And for that, they charge us 10 cents per hour. So that is about $73 per month that they keep this. And what does it contain? It means that they make it redundant, so it's not, the API server is not just on one IP address, it's load balanced, it's available. The database, it's backed up over regions, etc. So we kind of buy that it's available. On our part, we need to set up the system where the Kubernetes nodes run, and those nodes will then register to the control plane and kind of provide a place where we can run our workloads. So what does this picture show? It shows that on the right side we have our end users, service users. We get in the traffic through the load balancer, and that traffic is then load balanced onto the nodes. On the left hand, we have the control plane and the API server that we can contact, so we can tell what do we want to have to run on the cluster. And of course, not everyone can contact the API server, so we have authorization so that only authorized setup can tell what we should run on the cluster. On the top, we have this kind of OpenID connector provider setup. I will come back to that later on, what it means here. But all in all, this is the kind of simple setup to have your workload running on AWS Kubernetes service. Okay. So why would we choose this kind of setup? I guess everybody is familiar with cloud basics. It's with cloud we can have it working everywhere. We can have it in Australia or in US or wherever. It's just available, and we don't need to do anything special for that. Just set it up what we need, and it has built-in redundancy meaning that it's available as I was telling you before. And also the cloud makes it possible to scale. So if we need more capacity in the future, we just buy more capacity. It's easy like that. And if we don't need it more, then we just free it up. We don't need to buy the physical stuff to make it working. It's quite rather easy to set up. Of course, if you know what you're doing, everything is easy to do. But we are using infrastructure as code. So we're kind of coding also the infrastructure, saying that we want to have this kind of cluster and we want to have this kind of load balancer, and everything is set in the configuration that we can store in the version management. So we know that we can reuse that later on. So if something goes down, we can put it up in another place if needed. The orchestration, of course, that is the basics of Kubernetes. We want to just say that we want to have this kind of services running, this many, and the system looks after that it is actually what we have been asking for. Also, we want to have this automated deployments so that it's not made by hand, it's through CD pipelines. And the setup that I was showing you in the picture, that was just for one environment. So we have an identical setup for each, for the development environment, for the testing environment, and for production environment. And when they are done this way with the configuration, it's easy to do quite identical. Of course, we want to have some differences, that production has more power than development, that it utilizes the setups as effectively as possible. Cluster access is also pretty straightforward in this setup, and it, from customer point of view, of course, is cost efficient. So with this, we want to have continuous deployments so that we get continuous feedback that how well we are doing or how well the microservices are working. I guess this is the basics, but to run workloads on AWS, you need, of course, virtual machines, somewhere where the pods can run. So there is where the AWS virtual machine, which are called EC2s, provides the CPU, memory, disk space. And I wanted to show you this, that there is kind of two types. We have these on-demand instances, and that is such that you say that I want this kind of virtual machine. You get it, you pay for it, it's yours, you can stop it, you can start it, and it's yours until you decide to give it back. But that's what you're paying for. And then we have the spot instances, which is AWS spare capacity that we can get a discounted price up to 70 to 90%. Sounds good, right? So what is the catch? The catch is that it is spare capacity. So it means that if AWS wants them back, they can give us 2 minutes notification saying that we want it back. And then it means that we need to shut down the virtual machine, or they will do it for us. But before that, we kind of need to move away the workload to some other virtual machine where they can run. So to use spot instances, you can need this kind of fault-tolerant applications. And this is where Kubernetes is very good. So we have pods, we have kind of one pod running on that virtual, we have another. If the interruption signal comes, we just move that, shut down that pod and move it to another virtual machine which is running. Closely related is the scaling groups, and this is for the cost efficiency, so that when we have many requests, we want more pods, then we need more nodes, and these auto-scaling groups, we can tell them that, okay, we have identical virtual machines, now I need 5, then it just grows, and the virtual machines automatically registers to the control plane so that we can schedule workloads onto the new pods, nodes. Lastly, in this slide is an example of why don't we reserve on demand all the time. And if you have a lot of cash, then it's fine, you can use it on demand. But here is a small example of one virtual machine with 2 virtual CPUs, 2 gigs of mem, network perf up to 5 gigabits. If we take that as an on-demand, that it's ours, then they will charge us 2.16 cents per hour, which is roughly $16 a month, plus other small fees like routing charges, etc. But in comparison, and if we are using spot, then we can get as low as 0.6 cents per hour, so $4.7 a month. So as you can see, using spot instances is about 1/3 of the on-demand prices. So if you can run on spot, then it of course makes sense to use that. Going forward, here is a kind of setup to use the cluster. So only the one that has made the cluster, created the cluster, kind of have system master permissions, so can do anything to the cluster. But in AWS has made this config map where you can add additional roles to this and say what kind of permissions will they have in the cluster. For example, we have the administrator role, and when the user, for example me, assume that role, I then get also the system master's permissions in the cluster, so I can do almost anything. Okay, this kind of concludes the very basic setup of EKS on AWS. But as I said, this doesn't really make a working cluster. This is just the very basics. So we kind of need something else to actually make it work so that we can have our microservices running and work as we want them to. If we start in the bottom box with the core modules, and you can also see the list on the right side here. These are 3 required modules to make the networking work between the nodes. So we have the DNS setup, we have the proxy, and we have the AWS network interface. And this means that internally in the cluster, it will route the traffic where it needs to go. And why I listed those stuff on the right side is that when you have the cluster version, for example, 121 of Kubernetes, you need to have the matching add-ons of these core modules. And AWS provides you with the matrix that you need, and you can actually install them directly on the AKS. So it will do the basic setup very conveniently. Back to these add-ons. Here on the right side, we start with the traffic. That is our edge proxy, and that works in tandem with the application load balancer. So the traffic comes in from the customers through the load balancer into the edge proxy, which we have configured through the ingress resource. And through the ingress resource, we say that, okay, if it comes with this kind of domain or subdomain name, it will route the traffic to these microservices. But another very useful feature is this external DNS, which uses the same ingress resources. And it will configure the DNS server, where we are using here Route 53 of AWS, so that it configures the DNS server to point to the load balancer, and through the load balancer we get in the domain name to the traffic, and traffic routes it to the microservices. So everything is automatic. When a developer deploys a new microservice containing the ingress resource, which configures what kind of domain name it needs, it will automatically configure the DNS so that we can from outside call the microservices directly. Okay, going up in the upper right corner, we have the cluster autoscaler and the AWS node termination handler. And that works in tandem with the AWS autoscaler. I will come back to this function of the autoscaler, but basically it means that when it notices that now we need more nodes, more virtual machines to run to cope with the pod amount we need, it will tell the autoscaler that please spin up a new virtual machine for us. Okay, going up here to the left side, I sure you everybody agrees that we don't want any user credentials embedded in Docker images if we need to access some external database and such. And that is why we have this external secrets operator and reloader. Then again works with the AWS parameter and secret store. So here it's configured so that the external secrets operator have rights to read the secrets from parameter store, and then it creates Kubernetes secrets in the cluster, which the pods can then use to get the user credential it needs through environment variables, for example. The reloader is kind of because the secrets are evaluated when the pod starts. So if the pod is running and we go to the parameter store and change something, the pod will not know about that. But this reloader noticed that, okay, now the secret is updated and the pod has been configured to use the reloader. It will actually restart or create new pods that get the new values into use without us going there doing anything manually. In the middle we have a few, for example, RBAC manager, where we can specify that what can certain, what permissions can there be, or what users have what permissions in. For example, we can say that this user don't have access to this namespace and such. It just eases up that configuration. Metrics server, that's a kind of a basic add-on which enables to get metrics from pods and nodes. Several other features are using this to get the metrics. Last but not least, maybe one of the important things. Of course, it doesn't need to be Datadog. That's what we are using in this project. But having all this stuff working in tandem, and if you don't have any kind of idea of what is happening, then you are kind of moving in the dark. So Datadog agent are scraping logs, metrics, etc., and putting them to this Datadog portal. I will describe a few of this in more details in the next slides. As I promised about this autoscaler add-on. So the autoscaler tool checks that if the control plane tries to schedule pods and the result is insufficient resources, this will take up on that and start to scale the give us more nodes to have pods to work on. And the same way, if it notices that some of the nodes are underutilized, it will has a kind of grace period checking that and then remove them. And the service on AWS side was this autoscaler group making this happening. Of course, this we want to have for cost optimization requirements, but also if suddenly the request grows a lot, this copes with that spike hours as well. Then to Datadog. As I said, by this we know what's happening in our EKS cluster. What's happening to the infrastructure, for example, virtual machines. We also know what happens in the microservices. So it will collect logs, also Kubernetes events. That's one very good, so that we see, you know, that when you go into the cluster, the Kubernetes events for one namespace, they are there for 1 hour, at least by default, and then they vanish. So if you didn't go there within that hour, then you don't know what it tried to do. Metrics, as you can see here on the right side, we can see that at a certain time something has happened, and having this synchronized, we can have many different metrics and see that, okay, CPU was this high at this time, at same time we can see what's the memory consumption for the same pod, for example. So this Datadog portal, it gives our ready-made dashboards, log viewers, event viewers. We can make alarms so that we don't need to follow the boards every minute. We can have them send messages to Slack channels, for example, alerting that now something bad happened. Please check it out. Everything is customizable, and it not only takes data from Kubernetes, we can also have it with all AWS resources. So if some microservice uses some AWS resource, we can see at the same time what happened in that resource and what happened in the microservice. And of course, how much does this cost? This is the same thing as with cloud setup, that it depends on what you are using, how much you are using. It's not a certain amount that you get everything. It depends. So here is some costs that for logs, they take 10 cents per gigabyte for what's going into the portal. And they want $1.70 per million log events that are stored. So they are stored in this Datadog portal for 15 days. So that means that I can go from this moment and 15 days go to see what happened in that microservice at that moment. So that's kind of cool to have some insight of what happened. That being said, you can easily get this, or I jumped over this, if you use this Infrastructure Pro subscription. So they want $15 per host per month, so that we also get what happened on the virtual machines and such. So you can, depending on your size of your cluster, and of course, if you have development cluster, you have a testing cluster, you have production cluster. So you can have up to 100 virtual machines. So you can see that the costs can go easily up to several hundred of dollars and also up to several thousand of dollars. Okay. Then I wanted to highlight a very good feature that is possible in AWS at least. It's to have IAM roles for service accounts. That basically means that you can give individual pods certain permissions instead of you need to give the whole virtual machine some permissions. You can give the pod. And this is done through the service account resource in Kubernetes. And as I said, here is where the OpenID Connect provider comes into play. So when creating the cluster, enabling that for it makes it possible to do authentication through service accounts. So what we first need to do is to create this service account resource, and on that we specify what kind of role do we want this service account to have. Next, that service account is associated with the pod or the deployment through the service account name. When the pod is then created, the cluster behind will inject this kind of role RN and web identity token file into the pod environment variables, and then by using CLI, of course, but normally we have SDKs running in the pods. Having such SDKs that supports this assume role with web identity, we can get this temporary credentials that then will give us this temporary access key, secret access key, and session token. And by signing the requests we send, this will then allow us, depending on what this role here says, what permission this role gives, we can access stuff on AWS. At least I think this is a pretty neat feature and gives us these benefits, security benefits, that we can give only the permissions needed, and only pods that use that service account has those permissions, nobody else. It cannot access any other pod's permissions, and from auditability point of view, we know that who has used this, has accessed this AWS resource, and that's available in CloudTrail. So far, we have only been setting up our so there's some groundwork that needs to be done before kind of coming to this stuff that we actually can deploy our own services. A few words about that, how we are using it. We are deploying each microservice as an own namespace to gain this isolation. And namespace in Kubernetes, you probably know, that gives kind of virtual isolation, so that one namespace does not have access normally to another namespace. And for testing and review purposes, we are using the same development cluster. So in that sense, we are using an ID that when developer checks out and uses his own branch, makes an pull request, the pull request ID is used to deploy into that namespace, and will have its own ingress resource as well, so that that microservice under test is then accessible through the domain name of the pull request ID. So we have the normal development version, and then we have the version under work living in parallel on the same cluster. I think this is quite a neat setup, that you don't need to have an own cluster for that. Deployment. So we have the microservice projects containing the Kubernetes configuration. Customize we are using to make the specific configuration for example, development environment, for testing environment. So we don't need to multiply the configurations for each. We only override what is different for each environment. Crane tool we are using to deploy, and the crane tool makes sure that the resources are deployed and running on the cluster. So the pipeline waits until it has made sure that this new pod is up and running before it returns success. And if it doesn't do that in the timeout period, then it will fail that job and you have to go and look at what went wrong. So some basic configuration for microservice was the ingress resource, very important, so that we get the traffic in. Deployments are mostly using one emphasizes that when you are defining, you know that in Kubernetes you can say that this pod needs this much of CPU and this much of memory. And if that is not accurate with what they actually do, then you very quickly get unstable virtual machines, because it tries to schedule more pods running because it thinks it has more resources available than it has. So the memory consumption goes over what the virtual machine has, and you are watching that from Datadog that very much restarts and everything on your pods. Pod disruption budgets is also important when you are updating, especially on production, saying that when you're deploying a new version, you cannot take everything down and then put the new up. You can, with this disruption budgets, you say that at least, for example, 2 pods needs to be running all. Then it schedules new, and when the new are running and ready, then it terminates the old one. And this until the required amount is there. Horizontal pod scaling we are using, so we are using the incoming metrics, define this limits, that if this microservice receives this many requests per second, I guess, I remember, then if it goes over that within a certain period, it will request new pods, and the new pods of course will be scheduled somewhere, and if there's no resources available, then the cluster autoscaler comes into play and creates a new node. Okay. Maintaining. I think I forgot to say in the beginning, in the first picture, that AWS does not allow to use running versions that has come to end of life. So you cannot just once set up the cluster with one version and think that having it running for several years. So you need to kind of keep that up to date. And as said, the core modules should match control and data plane versions. And control and data plane versions could, please correct me if I'm wrong, differ one minor version. That's allowed, but nothing, no more. And all the add-ons, so all the Kubernetes resources also have the API versions. And when they are releasing new, they can say that, okay, you need to update that add-on because in version 122 of the Kubernetes, this version is deprecated. So that's one maintenance thing that you need to do. We do have semi-automated update of add-ons, so we kind of running a pipeline once in 2 weeks with checks it's semi-automated in that sense that we don't want to put it directly to production, because if something goes wrong, then production is down. So we want to see on the other clusters that is running well before we are manually then deploying it to production as well. You need to it's called rolling nodes if you are updating the Kubernetes version, because as long as the virtual machines running, having the kubelet, etc. running, they will be the old version, and after you are rolling them, then the versions will be updated. And one thing is, of course, to check from Datadog, is there something fishy going on? Do we have some virtual machine running 100% CPU or such? That's the normal business that day to day need to follow up, or have the alarms alarm you about this, and then you go and check. Some pros and cons. I didn't put that much thought into this, but there is probably other ones. But I would say that it's quite quick to get a working production grade solution running. You don't need to think about the fuss for the control plane. AWS takes care of that. You do have to, or I'm not sure if it could be automated. I don't think so. So you actually need to go and say that now I want to have it updated to the next version. And AWS releases quite tightly to the same schedule as Kubernetes releases new versions. So it takes some time, they test it, and then they release support for it. You easily get the redundancy and isolation, and you can make your own. If you want to have more beefy EC2s on production, that's up to you. You can configure that. And quite cheap. So the $73 is, of course, something that it costs per month, but that's quite minimal cost. And then it depends on how much you are using these virtual machines. That is where the cost comes from. Of course, the load balancer also costs, and it's something $20 a month, I guess. On the cons side, Kubernetes is still quite complex to learn about all the resources, and especially developers, they want to make the code that makes for it, not think about how do I get this secret map to this environment variable so I can use it in code. So that's kind of, but we have tried to make it quite easily. We have the templates, so they just copy paste the templates, and then they wonder why it's not working because they're using the copy paste. So something must change between my microservice and the next one. Okay, my mouth starts to get very dry. So this was my presentation. Hopefully I didn't tell so much things that was not correct. And if you have some questions, I try to answer them the best I can. But otherwise, thank you very much for listening to my speech. Thank you. question.
Quick question. You get the control plane from AWS. Can you like configure that at all, or do you get specific configuration?
There is certain parameters you can, for example, this OpenID Connect, you can choose to enable that or not enable that. So there is quite a bunch of parameters you can put additionally.
So if you like if you need to tweak a certain kubelet thing, can you do that, or like how fine grained is it?
Now you put a difficult question.
You might be.
Might.
Yeah.
I'm not sure, but they are quite strict about the versions, so you need to have a. But if you can configure some parameters for a kubelet, that I don't know. Haven't had need for it.
Okay. Yeah. How quick does the auto scaling work? You get like a spike.
Let's say minutes.
Minutes.
There is some grace period for if it doesn't just jump. And we are using this AWS cluster autoscaler. There are other ones that are faster. But the slowness of cluster autoscaler is because of the autoscaling group. But there are other ones that not using the autoscaler group that you can get blazing fast new up and running. And of course the virtual machine takes some time to start up. Yes?
As a lazy person, I'm interested, have you tried automating this and how much can you automate? So is there a script that I can download to set up similar cluster for myself?
So this cluster, what I have been showing you, we have done that all in Terraform. So it's just one Terraform apply and it will.
So there are no gaps.
Gaps, what do you mean by gaps?
Everything works with Terraform.
Everything is in Terraform. The add-ons is another. The add-ons are done through Helm file apply. So where you put them into the cluster, and that's not part of the cluster, but building the cluster, the application load balancer, setting up the virtual private cloud, configuring all the IP addresses, everything is in Terraform. So you can just, if I could give you the script, you could set up. And this is just one setup. I mean, we are using virtual machine, but there is also other possibilities in AWS to run workloads on not only virtual machines in this kind of setup. Yes?
Yeah, with spot instances, have you ever run into issues with there not being available spot instances?
We actually looked into that and started to worry that what happens to our cluster if we run out of those. And we have actually configured the setup so that we are using many different spot pools. And that is also the recommendation of AWS, that use many spot pools so that you should get an instance and instance types that are similar in type. That being said, looking at the metrics, we have spot instances running for a month in one row. So it's not that common.
Yeah, I've noticed with some other cloud providers that they say that, oh no, we're out of resources, we can't run this job right now. But
We haven't have any problem with not being able to get spot instances.
But then check, depends on the instance type, are you using the instances?
T instances, yes.
Yeah, usually those are available, freely available, but if you use M instances or something more, they actually do run out at some point.
Yeah, that might be the case, and of course that's region specific as well. That how much is, But with those instances we are using, we have no problem.
You can get the same benefits of using a cost savings plan with the specific instance types. You get similar pricing as parts. So if you know your baseline load, you can use savings plans to get the same kind of pricing, but you don't lose the instances at all. So that's one way of getting the same price, but not having to worry about the spots.
Yes, as I said, this is just one one possibility to do it like this, and of course this evolves over time, and new offers comes from AWS that makes other possibilities to do it cheaply. Yes. If nothing else, then again, thank you very much for letting me keep you here listening for half an hour, maybe hour. No, wonder my mouth is dry. Okay, thank you very much.
So let's keep a 15 minutes break and then continue like 10 past, so I get my laptop set up and everything. Nice. Sätt min skärm också. No. Ja. Big. Du kan ju ha sån där split också när det är OBS. Yeah. Yes, let's talk a bit about secret management through bank vaults. And I'm gonna do a longer who am I slide, so if anyone from the kitchen wants to join, they can walk in. But yeah, first a bit of me. I currently work as a systems administrator or DevOps engineer or SRE guy at Walkbase here in Turku. And as far as Kubernetes goes, it started back in 2017. Me and some guys from the university, we went down to Denmark and attended KubeCon there. And there I discovered the technology, and I've been playing around with it since. In my spare time, I like to brew beer. Then I'm also quite active in the Turku security scene. We have a local meetup called Turku Sec. And then I started to solve hack the box boxes as well, like quite actively. And given the recent internet events, I decided to pick up chess again, but I'm like really bad, but yeah, I thought I should mention it. So yeah, let's start quite generic. What is a secret in the Kubernetes context? This is what the YAML looks like. You have the kind secret, then you have some metadata. You need a name for your secret and a namespace. So it's a namespace resource. Then you have a type. I'm going to talk a bit more about types later. But then, as you can see, the data, it's pretty much like key value pairs. You have a key, and then you have a base 64 encoded value. If you do something quick locally, a smart tip is to use string data here. Then you can put instead of putting a base 64 encoded string there, you can actually just type regular English. So yeah, different types of secrets. Most common one is the opaque type. That's just arbitrary user-defined data. Then the second most common one is service account tokens. So when you create a service account, for example, I create a service called something, web server, whatever. I create a service account named web server. That service account gets a specific token that it uses to authenticate with the API server. Then if you don't run your own registry, you usually have some kind of Docker config, so your workload can pull stuff from your private registry. There are two types of those secrets, and then we have like extra stuff that has been added on as Kubernetes has developed. So why do I think that you shouldn't use regular secrets? For me, the biggest issue is the lifetime management. For example, I work with Lasse, and Lasse has access to, or Lasse is developing a service that has access to a database. When Lasse develops the service, he has access to the secret, so he knows the service username and password. And then Lasse decides to leave the company and move somewhere else. Then I have to go in and manually like delete the user, revoke the access, and so forth. And the same goes like if there is some kind of security incident, it takes quite a while to regenerate secrets, so the time to recovery suffers. Then another thing I think is bad with regular secrets is the audit logs. Like Kubernetes has audit logs, but if you have ever looked through them, like there is a lot of events, and when you try to find out like what has happened to this specific secret, it's not that easy to track down. So the audit logs, they work, but they aren't that good. Then secrets, they are, as any other object in Kubernetes, they are usually stored in etcd, and that's fine. etcd is a really nice key value database. One big gotcha with etcd is like if you just deploy it out of the box, it's unencrypted. So one minimal thing that you all should do is to encrypt your etcd. Another issue with having it stored in etcd is like if you have a multi-tenant cluster, the guys who manage the etcd, who maintains it, they might not, or they maybe shouldn't have access to the secrets, which they kind of do since they manage the etcd. So like it's not good to store sensitive stuff there if you don't trust the guys who manage the etcd. These two last points are like things that I have noticed myself. Is like it's really hard to see when the secret changes, because like you open up a terminal, you type kubectl edit secret Lasse, and then you notice like this secret looks correct. So when you quit the edit thing, Kubernetes will still mark this secret as edited, and then you have to go through the audit logs and see when it actually changed. And last but not least, like the default format, it isn't very Git friendly. Like it's friendly in the sense like it's just YAML, so easy to store in Git, but how to store it securely? Like you don't want to keep your secrets in Git for obvious reasons. There are many tools that handle this problem. I think the most popular one is well, the CLI tool is called kubectl, but the project itself is called why can't I remember? Sealed Secrets. Yeah, okay. what did you? SOPs. Yeah, SOPs is another one. With SOPs you have the issue, like SOPs it's a Mozilla project, and there you have the issue that you have one GPG key for everything. So then you have to keep that GPG key really secure. Why do I only remember kubectl now? Yeah, with the project is maintained by Bitnami. I can't remember the name now, but there, how that thing works is that you have a secret, then you run this CLI tool called kubectl, and then kubectl, what it does is that it encrypts the secret with a private key that is stored in your cluster, and then you get a custom resource. And then when that custom resource is applied to the cluster will unencrypt the secret and put it in the namespace. And the issue there is that like when you review something, you get like just a big glob of like encrypted content. And then although you just change one line in your secret, the whole glob content changes. So it gets really hard to like review stuff and follow up stuff that's happening in Git.
Can I ask a question?
Yep.
First of all, I like the info a lot. But you said about encrypting etcd.
Yeah.
Do you know if in public cloud any of the providers do it for you, or is it just like?
I think nowadays I hope it's really common, but at Workbase we run everything on prem, so we have to do everything ourselves. So like that's why I thought I should mention it. I would like to think that everyone does it, because it's really easy. Like you just have to provide etcd with like a key, and then it will encrypt it. So like.
Although if you use a public cloud, you don't necessarily have the key. So.
Yeah. Oh yeah, that's true. But you have like some kind of KMS where it would be stored. So yeah. That's another thing. Yeah. Okay, where was I? What we do at Workbase, we use something called GitOps, which means that you have like your whole cluster state in a Git repository, and then you give this access to this Git repository to a small operator that runs your cluster, and then the operator like continuously checks like does the cluster state match the state in the Git repository. And if it doesn't, it will like converge the state, so they will match eventually. And this is one of the reasons we started to investigate these different secret management solutions. And since we run on premise, what was really important for us is to find something that isn't like vendor locked in. Like we like our solutions to be free. We currently use vSphere, but if we would use something else, we want what we have developed to work on this new platform. And that's how we found a product called HashiCorp Vault. This is made by HashiCorp. It's the same company who has done Terraform and Packer these other big tools. What is Vault then? Well, if I would sum it up with one line, I would say it's API-driven secret management. As I mentioned, it's cloud platform agnostic. If I tomorrow want to run Vault in Google Cloud, I can just spin up a box and install Vault, and it's up and running. It's built on identity and policies. And what I mean by this is that if I want to access Vault, I need to authenticate somehow. This could be like through single sign-on, like Microsoft single sign-on or GitHub or whatever your company is using. And then your access is determined by policies. So this means that as a developer, I can put down my intentions as code, and then some security guy at my company can look through the policy and verify that I haven't done any mistakes. Another nice thing if you have access to Vault is that all the crypto or most common crypto functions are available as APIs. So if you need some crypto function in your service, you can just instead of importing the library and keeping the library up to date and so forth, you can just throw the thing to Vault. Vault will do the crypto thing and return your encrypted stuff. And then what I really like about Vault are these dynamic secrets. And what is a dynamic secrets? It's something that is created on a need to be basis. So for example, as a developer, I need access to this database or this AVS function. Instead of asking someone to create the access keys to me, I can just query Vault, and Vault will at that moment create the user account create the user account, and then all the stuff you get from Vault comes with a time to live. So I ask for access to a certain thing. I get access through Vault, and then I get this small timer. So for example, I need SSH access to this server. I ask Vault for SSH access. I get a private key from Vault, and then I get a time to live that tells me like this SSH key is guaranteed to be valid for 6 hours. If I need more time than that, I can always ask Vault for more time. But Vault can also choose to not give me access. Like it makes sure that no secrets are like lying around. I can show you next. So yeah, so this was what I was mentioning. Like first you authenticate, you get a token with a time to live. This is your token. It's valid for 12 hours. Then I use that token to ask for more secrets, and then when the 12 hours has passed, if I haven't asked for more time, all my secrets will like be deleted. And this is what it looks like in the CLI. This is a local instance of Vault, and I have chosen to authenticate using user and password. I authenticate as Dave, the developer. I insert my password, and I get a token. And here we can see the full token. You don't have to remember the token; it will be stored on your system. So as long as you have logged in once, you have a token, and then you can just use the CLI to like request secrets. This token is valid for 12 hours. I can see what kind of policies I have, what do I have access to, and then using this token, I want to ask for credentials for a database, and I just query the API. I get a secret back. We can see that this secret has a shorter duration. It's only 6 hours, so I will have to remember to keep it alive. I get a password and a username for the database, and this user was just created. Like as soon as I send the GET request, the user gets created by Vault. And like after a while of development, I noticed that I am not quite done yet, and here we see that the secret is renewable, so I am allowed to ask for more time, and I can do that. So in this example here, I ask for 12 hours more, and we can see that Vault gave me 12 hours more. like using the CLI is cool and all, but as coders we know that if you can do it in code, it's always better. So this is an example from a Go service, and here like we use the Vault SDK to do this automatically when the service starts up. So the service uses some kind of authentication method to authenticate. Then it gets the initial token, and then the token starts renewing in the background, is kept alive, and then the same goes for all the secrets that it requests. But yeah, since we're using Kubernetes, we can do better. Kubernetes is a great platform for building platforms, and using operators, we can like automate all this stuff. There are many operators, but we picked bank vaults. We mainly picked bank vaults because back when we started using Vault, bank vaults had all the features that we needed. It ticked all the boxes, and like there is an official operator by HashiCorp, but it doesn't have as much flexibility. Bank vaults is developed by a company called Banzai Cloud. They have like a full cloud platform that you can use, and with that platform you get bank vaults. What's nice about this operator is that it manages the full lifetime of Vault. Like you ask the operator for a Vault instance, it will set up the Vault instance for you. It will unencrypt the Vault instance, so it's like live and ready to use, and then it will check that it's configured as you specified in your YAML. Another nice thing with bank vaults is that it ships with a mutating webhook. What a mutating webhook is, it's basically a small binary that runs your cluster, and when you create, for example, a pod, the mutating webhook listens to that call. It changes the pod somehow, and then it creates the pod. And the big thing is that it provides your cluster with sidecars that abstracts away all the Vault functionality. So for example, I take a legacy service that reads a configuration. I want to run it in the cluster. I pretty much just have to put the configuration into Vault, and then I can configure the like in YAML. I can write down that when you start up, you should get the configuration from here instead, and the sidecar will like provide the service with the configuration. I have examples of this later, so you will see how it works. So yeah, what's so magic about this operator then? On the left there we see a picture from Bank Vault's official documentation. So if we start up there in the right corner, I want to deploy an app called Hello Secrets app. I take the YAML, I throw it at the Kubernetes API server. The Kubernetes API server spins up a pod, and while it spins up the pod, the mutating webhook takes over, contacts bank vaults, does the authentication, fetches the secrets, takes the secrets and provide them back to my application, and then it just keeps the secrets refreshed and running. How it does this is that it has the sidecar, so it spins up the pod. It has a small init container with a small binary. It takes that binary, copies it over to your main, or like mounts it so your main container can access the binary, and then it mutates the command or entry point of your container. So instead of spinning up the Hello Secrets app, it will spin up the bank vault's binary with the Hello Secrets app as a parameter, and that's how it like injects the secrets. So yeah, time for a quick demo. Let's do this first. Yeah. Need to check that looks good. So yeah, I have a small. No, I don't. Uh-oh. No, don't do this. See, this is why you should sacrifice USB drives. My Chrome crashed, Lasse. Oh, okay. I just think we do like this. Yeah.
Yeah, so I have this small to-do list. It's a small app. We can check out things, and we can add stuff. We can delete stuff. The code. Yeah, so the code looks something like this. As you can see, we need like DB host, DB name, server user pass, like just basic stuff, and then it can access the database. This is something that back in the day you could have a systemd service and some kind of config file who provides this, but nowadays when we run in the cloud, what we do is we use manifests and YAML, and I'm not sure is this big enough. Let's make it a bit bigger. Yeah, this is the YAML, and in order for the webhook to know which Vault instance to contact and so forth, what we do is we put these annotations on the pod, and first one is just like the first few ones are there, like it's TLS stuff. Then we tell the webhook how to authenticate with Vault. In this case, we use the Kubernetes API server, and then we tell the webhook to like keep refreshing the secrets, and where can I find my Vault instance. Down here in the environment variables, instead of providing it, where do we have? Instead of putting a real username or a password here, we use this Vault colon annotation, and this is picked up by the webhook, and then it's replaced. And as you can see, like most of the environment stuff here, we can actually have in clear text. And the same goes, like if we would have everything in a config map, we can put the same kind of annotation in the config map or in the secret, and this means that we can store all of this in Git, and it's also way easier to review. And like when someone reviews your PR, that person, if the guy has access to Vault, they can go into Vault, and I will show you the UI later. But there you can also see like history. So if I change something, what it was before will be there, and the new value will be there. And here in the YAML, I can actually, I'm not sure exactly what the syntax is, but I can like specify like use version 2 of this secret, use version 3 of this secret. So like you have the history there as well. And what does this look like in the cluster? So here we see this is what I get if I just query the YAML. You can see that the Vault values here, they are still in the clear text form. This is because they are like mutated by the small init server thingy, and we can see that Vault has been injected properly because the command up here has changed. Like here we see they use the custom binary instead of the original one. And okay, logs. This might be spammy now, but yeah, it's a bit spammy. But here we can see that I think we might, yeah, we kill it. Kill it. Let's see, hopefully it starts up. Yep, now we're going. Yeah, so here we can see see the logs from the container, we can see that like it starts up and it gets a new token from Vault, and then it starts to renew this token. This token has a time to live of 1 hour, so before 1 hour has passed, the webhook will actually automatically renew the token and keep it alive. Then we specified that we need a database, and this database secret only has a time to live of 120 seconds. So if I talk a bit more, we should. There we go. Down here we see that it has actually renewed the secret already. And in this case, we have Postgres as a back DB. So what it looks like on the database side is here we can see that yeah, now we have two temporary users there because I killed the last pod, but the second one will eventually get deleted. But we can see that it has created a temporary user, and the password is only valid a certain time. What happens is that when you renew the secret, Vault will go in and extend the validity of the user. Yes. Okay. One thing I didn't show now is that one issue I noticed with bank vaults is that if you have exec permissions to the container, so you can actually execute into the container, then it stores like all the secret values. It stores them in a local file. This doesn't actually it doesn't compromise the security model, because like if you have executable exec permissions into any container, you can always go in and just dump the secrets anyway. But that's something that caught me off guard. How we fixed it is that we use distroless images in production, so no like normal shell. And then as a second band-aid, what you can do is that you can just do a cluster role, and through role-based access control, remove the exec permissions from all users. Yeah, that was my quick presentation. Any questions?
At some point you mentioned that there was graphical user interface.
Oh yeah, good. Yeah, I forgot to show that. So back in the day when we started using Vault, this was a enterprise-only feature, but now it's actually bundled in the thing, and we should see if we can get. Here, like if I would have, if this wouldn't be a demo instance, I could pick like how would I like to authenticate. In this case, now I'm just gonna use the root token and log in as root. I thought. Is it HVS? Yeah. So here, this is what the backend looks like. We have all the kind of different secret engines. Here I added a key value store. This is pretty much a replacement to the regular Kubernetes secrets. There is one value here. We have API keys. Let's create a new version. So here the current values of these are fake key and another fake key. Updated fake key. And save. And now we can see here that we have this is the current active version with the updated value. but I still have the history here. So like if I notice something is wrong, I can always go back. And it's also really helpful to be able to quickly troubleshoot if something goes wrong. Why did it sign me out? As far as secret engines goes, it supports a lot of things. Like these are just some of the things. These are the official things you can request. So there you can see, like, you can request AVS credentials. So you can pretty much hand out temporary AVS credentials and AD and all these kind of things. Another neat thing is the transit engine. So when your app starts up, you can tell the app to generate something that something other needs to consume and put it here at this endpoint, and then your other service can go up and fetch the secret thing. These are just a small part of what's supported. They actually have like a fully fledged plugin system. So if you need something else, you can just code the thing yourself. It's quite simple to make a plugin, or you can use any of the open source plugins available. Now let's say my super secret to-do list got hacked. I can go in. I can check for leases. Let's do auth, Kubernetes, login. So these are the 2 pods that I spun up earlier. And if one of them starts to not behave, we can just we're not going to do force. We're going to do revoke. And what we did now is that we invalidated the initial token that the pods got. And when that token was invalidated, all the secrets that the pod used are also going to be revoked. So the old database users won't be there anymore. And now if I would have disabled the auth method that the pod uses, if I would have told Vault that this certain pod can't authenticate anymore, or like this type of service account can't authenticate anymore, then it wouldn't be able to ask for new creds again. But now what will have happened is that it will probably have restarted, and since the new pod could ask for permissions, it will probably spin. Let's see. Yeah, it's back. So now we have a new instance. How you configure who can authenticate this? Let's set alt. Yeah. Let's do Vim. Yeah, so down here there is a auth section. Here I can add like type GitHub, type AD, whatever I need. But in this case, I've configured it with Kubernetes authentication, or like this is one type to authenticate. Here I specified that the role name is to do, service account name to do, and namespace to do. So when Vault gets a service account token through the client, it will check like this service account token, what service account does it belong to, and if the service account name and namespace don't match, it won't be able to authenticate. And here now, if I develop a new service, I can just like extend the list, and then I just commit the YAML, and our GitOps pipeline will take care of getting the YAML deployed, and then the operator will configure Vault to match the desired state. This is also, I think, quite neat. The database access is handled through in this case, a super user, but this could also be like an unprivileged user who is only allowed to create new accounts. Initially, it needs to be able to authenticate somehow. I just picked the username Vault and password Vault, but then I set this rotate flag to true. So after Vault has initially connected to the database, it will take that existing password and rotate it to something else. So I can't sign in with the Vault user anymore because I don't know the password. and there is like no way for me to get that password either. Like I would have to create a new user if I want to change this database setup. More questions? Plus.
And so where does Vault actually store all this stuff?
Yeah, good question. You can pretty much store that stuff anywhere. Like you can store it in a file, you can store it somewhere up in S3, you can store it in a Postgres database. How it works is that all the stuff that Vault stores on disk is encrypted by a key. And that key is then stored in your cloud's KMS. You can store it in a hardware security module. Or you can, like in this instance, since I just run this on my own machine, what I get then is a few like decryption keys that I then can split among my friends. And then if Vault goes down, I have to call around. So like I call Lasse and say, hey, Vault is down, you need to unseal it. And then Lasse needs to quickly log in and unseal the Vault. Now I actually have the keys stored in Kubernetes, and the operator will actually see that, oh, this is a dev instance of Vault that has the keys stored in Kubernetes. So if the Vault is sealed, the operator will actually take care of the unsealing. So it's actually pretty neat, easy to run this in your own like small home lab or on your machine or whatever. But yeah, like if you store it on S3 and you don't trust Amazon, you don't have to worry, because like all the data stored on disk is encrypted. It's then decrypted by the server, like Vault servers, and yeah. Good question. Any more questions? Okay. Thanks for listening to me. What time do we have? It's really dark outside. It's 8. Well, let's keep a 10-minute break and verify if we are like yeah. I do. One.